Today I have prepared for you a very essential area that actually will enable you to gain more. Now, the area I want to cover today is all about probability, and specifically, I want to show you how we can derive the gamma PDF. That is the probability density function of gamma. Now, to begin, we need to come up with a function of gamma of alpha that I need to have gamma of alpha. The function of gamma of alpha usually is that I need to get the integral of ranging from 0 to infinity, then exponential of that is negative y, y alpha minus 1, then you need to be having dy because you are integrating with respect to y. So this function here is very important as far as deriving the PDF of gamma is concerned. Now, after knowing the function of gamma of alpha, you are now supposed to come and say now that now let y, which is the y's I'm seeing here, be that is x over beta. Yes, so let y be x over beta. In that the place of y in my function here, I'll just substitute with x over beta. Now, after letting that, indeed I can get that is the dy dx, having known the function or the equation of y. Now, therefore, what is dy dx? So my dy with respect to x shall be, you just come here. Remember y is equals to x over beta. So for you to differentiate this, what you shall just come and say, remember if I have x over beta is the same as me having 1 over beta x. That is it. So how can I differentiate 1 over beta? To differentiate 1 over beta is just the same as 1 over beta then dx. That is it. So I'll end up by having now 1 over beta dx. Now, since I have the dy as well as the value for y, I'll now use substitution method to substitute where dy is. This is what I'll be writing. I'll be writing 1 over beta dx. Then where y is here, I'll just be writing x over beta. And I shall have just done. So let's see. Now I'll come now from the function of gamma of alpha that I have gamma of alpha being equals to now the integral, that is the integral from, that is 0 to infinity, of exponential negative y. So this way my tax begin. So I'll come here and say exponential of negative y. And remember we said y is equals to x over beta. So meaning I'll substitute y with x over beta. And I shall just have done that. So it is the same as negative x over beta. Then if you intend, you can use a bracket to separate the values of y as well as the negative part. Now after that, I'll now come here now and substitute this and the y because I want my function to be with respect to x but not with y. Now I'll come now and say it is y, and what is y? Y is x over beta. So I'll substitute here with x over beta. So I'll come now and say that it is now x over beta, which is this y. But what was y? Y was raised to alpha minus 1. So I'll come and say it is alpha minus 1. Now after that, remember I'm having dy here. Remember we said that we need to substitute this dy with what was it? Dy was 1 over beta dx. So just substitute. So I'll come now and say that instead of me having dy here, I'll be having the value of y that is 1 over beta dx. That is it. So I'll come here and say it is 1 over beta dx. Yes, so probably it is very important and crucial to understand the concept I put across here so that you'll be able to understand the proceeding ones. Now after that, you are now supposed now to try to solve this bracket. Remember, this bracket is better to solve it in that the power here will affect everything in this bracket. So the first step is to break this bracket by solving it using the power. Now I'll come now and see now that this one is the same as now gamma of alpha is now the same as the integral of infinity, and that is 0. Then I'll begin here. It is exponential of negative x over beta. This one is just leave this one constant as it is, but how many constant shall be here? So this one I'll just write it the way it is. So I'll come and say exponential of negative x over beta, bracket that way. Then when I come here now, remember the power here, that is alpha minus 1, will affect the x part as well as the beta part. That is it. So I'll come now here and say now it is now x raised to alpha minus 1, that is alpha minus 1, this one is alpha. Then the same alpha minus 1, because it was a power, it will also affect the denominator here, that is beta. So the beta here will be beta raised to alpha minus 1. So that is over beta raised to alpha minus 1. Now after that, just join it using this. So I'll come and see now it is 1 over beta. My dx is just a constant. Now friends, after writing this by solving that, you are now supposed to use the law of indices to break that is the denominator here. Remember the denominator, I'm having base beta as well as the base beta. Remember, this beta means that the power is 1. And the power of this other beta is alpha minus 1. So, you use law of indices that states that when you have two bases which are similar and the sign separating the two bases is multiplication, what you do, just take one base, then just add the powers. So I'll come now and say that I'll be taking one base which is beta, then I'll add the powers. Remember, this beta is raised to 1. If it has no power, we assume that it is raised to 1. And that shall be my next step. So I'll come here and say that there is gamma of alpha now being equals to the integral that is infinity 0, then exponential of negative, that is x over beta, then you put a bracket that way. When I come here now, this x raised to alpha minus 1 is just constant. So that is x raised to alpha minus 1 over, because when I multiply this by 1, I'll just remain with the same power. Now at the denominator here, that's my main constant. So I say you just take one base. So the base is the beta. Just take one base, that is beta. Then now add the powers, because I say the sign separating one base to the other is just multiplication. So that's what I do. So I'll come here now and say it is alpha minus 1, which is this one, and have this power. Then I add this power. This one is 1. So I'll come and add 1 there. Then my dx is just but a constant. Now after reaching here now, you can work out this, because negative 1 plus 1 probably is 0. You will end up by having beta raised to alpha alone. And therefore, that one marks my next step. That states that now come here now and say it is gamma of alpha being equals to now that my integral is the same integral here. That is integral of infinity 0. Then I have exponential of that is a negative x over beta. I then just put the bracket there. Then remember I say that it is x raised to alpha minus 1. So I'll come here now and say that it is x alpha minus 1 over, when I come here, already I see that negative 1 plus 1 is a 0. So I ended up having beta raised to alpha. So I'll come here and say that is beta raised to alpha, and probably it is dx. Now after this, you need to know that for you to come up with a PDF, the assumption is that the integral of the provided function must sum up to 1. And therefore, you need to ask yourself that how can I get 1 to be a summation of the PDF function? And therefore, I can only get that by so dividing by gamma of alpha on both sides of the equal sign. That is it. So I'll come and say now I divide by, that is gamma of alpha. I also divide everything here by gamma of alpha, which is the same as me bringing gamma of alpha here. That is it. When I divide this side with gamma of alpha, is that the same as me putting gamma of alpha at the denominator side. Whereby this one will cancel the other, and we will end up by having 1 being equals to now. After that, just write the remaining function, and that is that. So I'll come and say now that it is an integral of infinity 0. Then here there are many ways of writing this. First of all, which is very essential, is that because the sign separating the exponential part with the other side is a multiplication, and therefore you can let your this second part here comes first is when exponential follow. That is being done by so saying that it is x alpha minus 1, so x raised to alpha minus 1 over this one here. So it is gamma of alpha beta alpha. Then I now join the exponential. So that is exponential of negative x over beta. And my assumption is that is dx. Now friends, after coming up with the summation to be 1, you need now to finalize by now writing the provided PDF. So I'll come now and say, therefore, the PDF being framed as fx is now equals to, we just write the probability. Remember, this one is the probability. So just come and write this probability. So I'll come and say that it is my x alpha minus 1 over gamma of alpha beta alpha exponential of negative x. This one is the x, we write it very big. So that is over beta. Then after writing this, remember that is the PDF. After writing the probability, you need now come and write the limits. Remember here we say that the limits are from 0 to infinity. Meaning I'll come up here and say it is starting from 0. They are x's, and therefore you write x. Don't write any other letter here apart from x. Then it is up to infinity. So you just write infinity there. Then you finalize by saying 0 or elsewhere. And this one shall sum up to your PDF. Now, after doing all that we've done, knowing the concept, the basic concept that I'm making here, and coming up with the provided PDF, you shall just gotten the PDF of Ghana. And that's how you are supposed to write the PDF of Ghana distribution. Otherwise, ensure you subscribe to the channel so that you keep receiving more notification concerning what I'm concerning. See you in the next class.